Is the cake pattern still useful? I'm going to try to answer that question in this video. There are a lot of articles about this pattern. I believe that most of the examples on the internet make it sound way too complicated, and I don't think they do a good job explaining what the advantages are. So I'm going to try to do that here. Let's look at this example, this use case. So first of all, this is a pattern that allows you to do dependency injection, something, the type of thing, the sort of thing that you would use Juice or Spring dependency injection for if you were in the Java ecosystem. The great thing is that Scala offers something out of the box that just plain language features that can do this sort of dependency injection if you follow a number of guidelines. There's something called self-type annotations. So let's look at this example here. I have a dashboard that is using a user repository. That user repository is using a DAO. So this is basically a three levels of dependency injection. There's something called self-type annotation in Scala, which allows you to say something very similar to what you do when in Java you declare that an interface is injectable, that you want the dependency injection framework to instantiate the class. In this case, what you do is that you declare, let's say we look at dashboard, and I'm saying this dashboard requires a user repository to be injected. This is called a self-type annotation. Then a user repository, in turn, expects this a DAO implementation to be injected. And then we can go on and on and on. This is just three levels. You notice that the three classes, it's actually, well, it's four, but it's actually really three because Mango DAO is an implementation of DAO. So the three components here that we are playing with, these are the building blocks. And then what we do is, so we have different kinds of DAOs, data access objects. We have, and we have one instantiation of that, a Mango DAO. We have a user repository, we have a dashboard. And now we would like to construct an application dashboard. What we do is create a class, declare a class, which extends dashboard, mixing user repository and Mango DAO. So what this self-type annotation means is that when you instantiate this class, so when you instantiate a dashboard, a user repository implementation must be injected. When you instantiate a user repository, some implementation of the DAO has to be injected. So obviously, when you create a class like this, app dashboard, which mixes in, it creates a dashboard and mixes in user repository and Mongo DAO, you will have everything that you need for self-type annotations, and you can create an object of app dashboard here. So this is my application object, and call the main method on it, print dashboard. So I put another method in here just to illustrate that each of these traits can have other methods. Some depend on the implementation, some don't depend on the implementation. So let's say that the main method, the external method here is print dashboard. I'm calling that here. So if I run this, we will see the expected result, which is it's going to print dashboard is going to use the user repository injected, which in turn will use the Mango DAO injected, and it's going to print out Joe, Jill, and Mary. This is what we would expect. So the question is, and I think this is where most articles drop the ball. They don't explain what the difference between a self-type annotation. So what the difference between this is and extending a class. So let's look at, by extending I mean user repository could extend DAO instead of declaring a self-type annotation like here. This could say extends down, right? So what's the difference? There is a difference, and to explain what the difference is, let's look at inside dashboard. If I look at what methods are available to me, let's say here, I'm going to see that print dashboard is obviously available because I declared that here. Print dashboard heading is obviously available because that's another method declared in this class. And print user info is also available. But if you guys look at this list, it doesn't have anything else. In particular, it doesn't have get user list. In other words, what's happening is that you don't have when you have a self-type annotation, you're not actually extending the your interface with your implementation classes. You're not mixing in all the methods that would come with your implementation classes. In other words, if you have hundreds of classes being mixed in like this, so here we have three components, three traits, but we could potentially have hundreds of them. You might end up with thousands of method calls here when you do a listing as you're mixing them together. That's not good. That is very messy programming, and that is what the self-type annotation helps with. Now, to make it a little more clear, let me show what it would be like. So again, there are three methods here, right? The only thing that comes from my implementation is print user info. That's the only thing I care about because that's the only thing I required to be mixed in. User repository. User repository has one method, print user info, and that's the only thing that's coming from the implementation. Now, if I change the self-type annotation to to extends user repository, extends user repository, and this becomes a curly. And user repository, this I have to change this as well. This extends DAO. Then if I run it, I end up with the same thing, seemingly, at first glance, right? It works the same, except for one big difference. If I look at this component that is mixing in one implementation class, it's only mixing in one implementation class, user repository, but yet it can see get user list, which is actually not something it's requiring. It comes along from DAO, which this level, this dashboard does not care about because that's not its direct, it's not one of its direct implementation classes. So that's not good. I should not be able to call this. Just imagine if you had hundreds of components and thousands of method calls. This would be a very messy class hierarchy. What you can do, so that this is why you would use a self-type annotation. I go back, and if I look at it again, the methods I don't care about are not listed. That's beautiful. But I still have one problem though. So this is the essential difference between a self-type annotation and extending a class with an abstract class or a trait. Because extending it with an abstract trait would also require the methods, but this way I'm not extending the interface. I'm just declaring it's required. So it's great, but it's only solving the problem for these components. So what you just seen here, that I eliminated the methods that I don't care about on that level, it only applies to these components. At the end of the day, when I mix in app dashboard, when I create my final component, and I mix in all the required components here, then on that level, even though I'm using the self-type annotation, I'm going to see the methods I don't want to see as well. That is because here I'm actually doing the extending. But when we're looking at the components in the cake that we built, right? Then there I only saw the immediately required implementation base classes. But here, when I'm actually piecing together my component, what I want to use, not the building blocks, but the final component. Because I'm mixing in all the required components, I see all the methods. That's not a good thing. So we solved the problem, but not quite. We're very close. We have to eliminate these unintended other methods from my final component as well, and then we're going to have a really clean interface. So let's see how we do that. I created another version of this. The difference here is that when I'm mixing in, when I create my app dashboard class, so everything else is the same here above. These are the same exact things. I have a DAO with one implementation. I have my user repository and the dashboard. But my final component, like these are my building blocks, right? These are my reusable pieces. But when I build a component that I'm trying to use, here I had that problem that I saw the methods that I don't care to see because they are implementation methods. What I'm going to do here is when I mix in this class, I create a class app dashboard, and instead of extending it and mixing in the required components directly, what I'm going to do is I'm going to create inside it a private val which does all the mixing in. So this impl is what's doing all the mixing of a dashboard, of a user repository, and a Mango DAO, right? So, or a DAO actually. If I look at impl, this does have the method I don't want to see because it's an implementation method from up here. I don't want to see that. But because this is a private val, what I can do here, I simply forward the methods that I do care to expose. Now, app dashboard, if I look at it here, if I look at it in my application class, where I instantiate app dashboard will only have the one method I care to expose in my component. So basically, this allows me to create very clean components with only the publicly exposed methods that I care to see. There are three levels we are working here on. There are the traits that we are mixing together to build our cake, right? To piece together or mix together functionality. There's a final component that pieces everything together. This is what we will use in our application. This is usually specific to the application. And this is how we are using it. We just declare that component, and we can call the methods the public methods that we exposed. That's it for today. Thanks for listening.